Okay, so welcome to the session. The session is in relation to calculations of some kinetic problems. This is basically a very sort of typical problem that you'll encounter while you are studying the kinetics. In this problem, normally you are given different experiments of a certain reactant, and then you are asked to find out or to write the rate law equation to find the order of reaction with respect to the reactants, and also to find out the rate constant and to deduce its units. Okay, now in this case, to start with, we will start with the first requirement. In order to write the rate law of a chemical reaction, basically R here equals to a constant times A and B. And this A is raised to the power X and B is raised to the power Y. Right? So this is the rate law. Now, X and Y are basically the second requirement that we need to find out. So the order of reaction in this case of A and B. So A, it will be the order of reaction of X will be the order of reaction of reactant or with respect to reactant A, and Y will be the order of reaction with respect to the reactant B. Order of reaction means how much the concentration of certain reactant will impact the rate of the chemical reaction. So let's see what strategy here we can do in order to find X and Y. Now, A is, as I said, in respect to A. When you want to find A or B, you need to look at the concentrations, how they are changing. And you need to pick two rows where the concentration of one reactant is constant and the concentration of the other reactant is changing. Why is that? Let's look at the first and second row. In the first and second row, we can basically look at the concentration of B, it's constant. And the concentration of A is doubled. So basically, from rows 1 and A, we can find out the concentration with respect to A, which is what we call that X here. But we can't determine the B. And the reason here is, since concentration didn't change, it will has no impact of on the rate of the chemical reaction. But since this one has changed, then we can say that the change in concentration attributed or may not attributed to the change in the rate of the chemical reaction. So how do we do it practically? Basically, it is basically the ratio, take a ratio between the two rate equations. So in the first case here, as I said, this will be ignored because the concentration is remained constant. So we have 0.2 divided by 0.1 equals to the rate which didn't change, which is 1 times 10 of power minus 3, and then same here. Here you have to put this raised to the power x because you want to see how much the change in x is affecting the rate of chemical reaction. So the answer here is 2 raised to the power x equals to 1. So what is the value of x here that if you were to use it as an exponent, it will give you the value 1. The x here must have been 0. In other words, the change in concentration of the reactant A didn't attribute to any change in the rate of the chemical reaction. Okay. If we want to find out the other requirement, which is the order of chemical reaction in relation to Y, then we need to choose another two rows when where the concentration of A is constant and the concentration of B is variable. So if we look at row 1 and 3, 1 here has a concentration of 0.1 3 has a concentration of 0.1. So the concentration here didn't change in 1 and 3. If we look at B, concentration was 0.1 and then it became or was changed to 0.2. That means it was doubled. So let's do the same thing again. So here we will ignore the concentration of A because it didn't change, and we'll be looking at the concentration of B. So the concentration of B in this case, or the order Y with respect to B, it will be 0.2, 0.1, and this is, we call that Y, equals to, we use the same numbers here because we use this divided by the top. So here we would say 2 times power of -3, and this is 1. Okay, so that basically is 2 raised to the power y equals to 2. And obviously y must be 1 in this case. So the rate law here, if we want to rewrite it correctly or in a complete form, rate law equals to K A to the power 0 and B to the power 1. Fine. And therefore, basically, if you want, you can also write it this way. Rate equals to K. K is the rate constant. This all together is 1, so you don't write it. And then you can say just B to the power 1. Okay. So this is the, we found out the rate law of this reaction. We found out the order in relation to A and B. And now we want to find out the rate constant, and also we want to find out the units. Okay, so just to, well, okay, to make some space. Fine, so we know that this term here is 1, and this is basically 1. Okay, so in order to find out the rate constant, all you need to do is to pick any of these rows and apply directly in the equation. So we can take the first one. So the first one, the rate was 1 times 10 to the power of -3 equals to K. And here we'll not consider A because everything is 1. And B here is 0.1 raised to the power 1. Correct. Okay, and therefore basically K equals to 10 oops. Yeah. And then this is basically fine. Now, this is the K of this chemical reaction. Now we want to find out the units of this K. To find out the units, basically you just need to consider what you have, what units you've used in each term of the equation. So for the rate of the chemical reaction, the equation was, or the units were molar per minute. is equals to K. And for the concentration, what would you use? Yeah, it is the molarity as well. Fine. So instead of molar, you can say mole decimeter cube. So instead of capital M here, you can replace it with mole decimeter cube. And this is most likely that you will see in the exam. You may not see this capital M, but most likely that you will see it this way. Fine. So if you want to find out K, it's -1. So therefore K equals to M -1. So this is the units for K. And this is really important to remember that each of these chemical reaction has its own unit for K because each rate equation is different, and therefore you need to work out each equation separately. There is no specific unit for K, but each K is different. Okay, now let's take another problem here. Okay. This is problem about an MCQ. Okay, it says a rate investigation was carried out on a reaction involving three reactants X, Y, and Z. The concentration of the reactant were varied, changed, and the relative rate of the mixture was determined. Fine. So, and they're telling us what is the overall order of the chemical reaction. Now, the overall order of any reaction, and maybe we forgot to do it in the first one, is the summation of the different orders with respect to each reactant. So, for example, if we have reactant X and reactant Y, reactant X has an order of 1 and reactant Y has an order of 1. So when you add the two, the overall reaction order will be second order of 2. So here is telling us that the reaction is 0 order with respect to Y. So Y here, basically the change of concentration doesn't affect the rate at all. So what is the overall order of the reaction? Now to do this, you need to find out the reaction order of X and Z separately and then basically add them together to see if the answer is 0, 1, 2, or 3. Okay, so how can we look at this? Now let's look at equations 1 and 3 or 1 and 2. In 1 and 2 here, we can't really use it because both X and Y are changing and sorry, we can use it here because we were told that Z is 0. Fine. So we were told that the Y is 0. So we don't need to look at it here. The Z here is fixed, and therefore we can figure out the order of chemical reaction with respect to X from the first and second row. Okay, so how can we do it? Just as we did before. So 4 divided by 1 equals 2. Here, 2 minus 3. And here, 1 minus 3. Here, basically x. Don't forget that it is the concentration, what we raise to the power. And therefore, basically, we have 2 to the power x equals to 4. And therefore, x equals to 2. Okay, so this is the first thing. Now we need to find out the other one, which is the z. In relation to z, if we look at the different rows, we will not figure out two rows where, you know, there is a fixed value for the other reactant where we can use it. So let's say, for example, 2 and 3. 2 and 3 here, the x is variable. We know the y, we're not, bothered about it, and we can use basically this to figure out the z. Let's see how we can do it. Okay, now the relative rate here, relative rate is 0.524. This equals to the z, which is 4 divided by 2 minus 3, and here minus 3. And here I will raise it to the power z. And x, which is 5 minus 4 divided by 2 to the power of 2, because we know it is 2. And this one here is z. So I'll just put it in a different color so you don't mix up between the 2 and the z. Fine. 2 equals to 2 raised to the power z, and therefore basically z equals to 1. So we know that x equals to 2 and z equals to 1, and therefore the correct answer will be D. Okay, so I hope these two examples were interesting, and I hope that we answer more of these questions in the class. Thank you very much.